So I'm going to talk about creating some collaborative editing UIs today. I hope you all had a good lunch. So the web was always built for collaboration. The original intention was for information sharing between universities, and way back in the day, you used to upload some HTML and you shared the URL for that, and that was collaboration in its purest form. And if you fast forward a few years, we got some pretty awesome new services like Dropbox, which allows you to synchronize things, files. And you have Slack, which allows you to collaborate in real time, chat, share files, all that kind of good stuff. And for us developers, we have GitHub, which allows us to collaborate on code. And yeah, bug reports and all that kind of good stuff. And one of the prime examples is, of course, Google Docs, which allows you to collaborate on documents in real time, which is probably one of the most powerful examples. And if you go even further than that, you have things like Prisma, which allows you to collaborate in real time on design. So this is kind of super impressive if you think about it, because you can even see the cursor positions of different people collaborating in real time. And so we've come quite far in terms of building these really rich experiences. So this is me. My name is Espen, and I work at this company called Sanity, where we make a headless, real-time, collaborative CMS. So I want to share some of the insights that we've learned over the years while building it. Not all of the things that I will be talking about is things that we have actually implemented. It's just wisdom from our perspective. So I'm here to tell you that this is only half the story. Like these services that I introduced you to previously, they're only half the web, or less than that. So for instance, when we order lunch at work, we use Slack and emojis to actually say what we want for lunch, and someone has to actually go in and place these orders with a restaurant website because it doesn't have any collaborative feature for ordering anything. So that's one example of things that could be done much better. Ordering airplane seats or just plane tickets in general is a huge pain in the ass if you think about it, because you have to sort of synchronize which dates was it, are you sure that you've picked the right date, then we have to go in and tell each other on a different medium like which seats do you have and hope that you'll get the one next to the other person. Just another thing that could be done much more collaborative. Paying for bills at a restaurant is one of the examples that's still a bit too painful if you think about it. It's 2019, it should be super simple to just split bills everywhere. Or being able to find a restaurant in a strange city and just getting some tips and knowing where to go. Add suggestions with your friends, maybe vote on them. There's all sorts of cool things that we could do if we took collaboration a bit further. So this is an example of, I tried to use this slide building service while I was writing this talk. And something happened in the middle of it, and I got this prompt here, which basically says there's a new version available, which is weird, because I was the only one actually writing it. And I had two options at this point. I can either ignore, which I don't know what happens then. I don't know which version is apparently the new version. Or I could reload and then I guess lose all my changes. So it's there's some room for improvement in a lot of areas. So I think truly collaborative services is kind of the next evolution, taking the steps that I talked about in the first couple of services and applying sort of the same collaborative features and maybe even going further than that for our own services. So how do you create collaborative UIs? I'm going to start by saying that real-time collaboration is really hard, so I want to start by just looking at async collaboration instead. So that's the read, modify, and write pattern, which I'm sure you're all familiar with. You're probably using this for when you're editing code. So like you get some file, you modify it, and then you commit it and push it. And that's the same thing that we're doing with forms for ages. And if you think about it, most editing UIs are actually multi-user, because if you can open the same editing experience in two different browsers, then that's in theory actually a multi-user or at least a multi-window UI. you might not just be thinking about it that way, which is one thing that can lead to problems. So for instance, in this case, this is GitHub releases, and I can have this open in 2 browser windows, and so it's multi-user, easy. But if I put in different content in each of these, and then I click update release at the same time, what's going to happen? It's kind of a race. It's a data race. You probably want to address this somehow. So hopefully the backend uses transactions so that you won't run into these weird situations where maybe there are multiple backend entities like database entries that rely on the same thing, which could make it even potentially worse. You could end up in this situation where you have 2 different versions of the same document. So solving this usually involves locking. There are 3 approaches generally. So option 1 is to be optimistic about it and just hope that there won't be any changes. And if there are changes, you include this, or to check if there are updates, you include this last known revision or a timestamp for when the document was last edited. So that can prevent this situation from happening where you override someone else's changes. The problem is this with this is of course it's the most annoying time to be informed of a conflict, because you're done writing your new content and you click update and then you want to go home, but then you get this message saying there's been a conflict. So how do you resolve that? Do you try to resolve it? And if so, we're stuck with the same example that I showed you earlier. You can either reject their changes possibly without knowing what that content is, or you can just say, okay, I want to use theirs and I'll just redo everything that I've done, basically. And maybe if you're really lucky, you have a UI that at least allows you to sort of copy that to some external place so you can actually try to reapply your changes. Option 2 is the opposite, which is pessimistic locking. So that's when you lock the entire document so that only a single user can edit it at the same time. This isn't a great UI, but at least you won't run into these situations where you try to save and it's too late because someone's done some changes. Now you at least get a message saying someone is editing this, so you have to wait. But of course there are problems with this approach as well. You have to have database entries which lock that document, and with a distributed system that can be quite challenging. And you can also have multiple browser sessions open. So if you have the same user as 2 browser sessions, you probably also want to have locking on that level. So only one of the browser windows have an identifier that sort of wins. But there's also, like, when do you unlock that? So what happens if your computer runs out of battery in the middle of your editing? Is that document stuck in a lock state forever? Or do you need to implement some sort of automatic unlock feature after a while? So at this point you probably want to implement some sort of thing that pings the server and says I'm still here. But that could even be trickier, because maybe you leave the computer open and then you just leave your office for the day, and then that's document locked for. So maybe you need some kind of inactivity thing. My point is that it gets tricky to think about these things, and there's a whole lot more logic to it than a simple lock should imply. Yeah, I'm gonna skip that. Option 3 is, of course, to pretend that it's not a problem, which is actually, unfortunately, what seems to be the industry standard. So GitHub releases, as I talked about, has this problem. I had the same problem with arranging a meetup. Someone edited a little typo and just replaced everything that I wrote. They didn't get a message, and I didn't get a message. So they were happy, and I was happy until we both checked the meetup page, and they had like half the actual information. So maybe we can try to resolve conflicts. But if you think about it, this may be familiar to developers, but I guess if I was to present this to my mother and ask her to resolve this conflict in this way, then she wouldn't really know what to do. So it's hard to make these merge conflict tools in an understandable manner. And even worse is if you have something super visual like this. How would you ever plan to resolve a conflict in a visual tool such as this? So hats off to you if you actually implemented a proper conflict resolution. I'd really like to speak to you if you have implemented that at some point, because that sounds like a daunting task. But maybe real time isn't that much harder if you think about it, because humans are built for thinking in a real time manner. We're not used to this asynchronous way of thinking. So if you go and get a cup of coffee and sit down at your desk and then start working on something, and the first sip you're gonna take, the cup is empty. That doesn't happen. At least you'd see that someone came in and actually emptied that cup for you and just stole that cup away from you. So it creates this really illogical states that humans aren't used to resolving. So maybe it's just easier to try to implement real-time collaboration instead. So if you think about it, this is much harder to resolve than change or conflicts in this case. Because you can see what's going on, you can usually don't edit the same portions of the text at the same time. It's just easier. So real-time collaborative UIs are better for everyone. I think we can agree on that. When we use the service like Google Docs, I think that's a much better experience than sending each other text files and trying to resolve differences between those. But you might need a different backend than you have now, or at least make some changes to cater for this. So let's try to think about the different pieces that are involved in making something real-time. There's, I'm gonna go through this one by one. So there's transports. You'll want some kind of streaming transport. So WebSockets are probably your best bet because they're usually supported nowadays. But if you have something which is more like distributed and in a way that you can share the state between all the people that are working on it and then commit at a later time once you're like confident with the changes, then you could potentially solve this with something like WebRTC, which allows peer-to-peer connections. You'll still need some kind of WebSocket or something like that to actually let the peers discover each other. Server-sent events and post requests could also be a solution, but it has its drawbacks. For state management, that's sort of the hardest part to solve in a lot of UIs. But in real-time collaborative UIs, I think the only real logical thing is to have make sure that you have like a one-way data flow and have some kind of global store. So this is kind of similar to Redux, for instance, where you make sure that all your actions go through a single location. But this is extremely important within the real-time setting because you're going to be emitting these small patches, and you will also be receiving patches from the server. And so it's really important for that state not to deviate inside of components deep down in some React tree. So you want to make sure that the state is like shared for the entire application and then distribute those down to the components that need to know about the state. As for patches, in a real-time context, you want to send these patches very frequently, especially for things like text editing. It's extremely important to see that someone else is editing this paragraph right now. And you want to do this as fine-grained as possible. So even if you're not doing text editing, but more structured things like inserting elements into an array, you want to make sure that the patch includes as much context as possible. So instead of saying, I want to set index 3 of this array to this value, you want to say, I want to insert this entry after the element in the array which has these values, for instance a key or something like that, because that's easier to, if two people are editing the same index in that array, that can cause conflicts. But if you say that I want to insert something at that location or after that element, that's easier to apply. So yeah, think about as much intent within the patches as possible. And algorithms like diff match patch provides an efficient and robust way to apply text changes in a real-time setting. These normal Git diffs aren't really meant for anything but line conflicts. But things like this, as you can see on the right here, is the diff match patch matching the character on a character level, which things have changed. Conflict resolution is an extremely hard and tough topic so I'm not going to even try to get too deep into these things. But there are generally two schools of thought, which is operational transforms and conflict-free replicated data types, or CRDTs, which is sort of a way to express how you want to emit patches and resolve conflicts and get back a shared, like a eventually consistent state. Sorry. So if you're interested in this, there's like tons of academic papers, and there's lots of people that have been working on this problem for ages. And I don't think there's like a go-to solution that just works necessarily. But there's some interesting new things that's been coming out recently. For instance, auto merge, I think, which is like a CRDT based on top of JSON, which is fairly modern and should solve most of these kind of issues. Another interesting thing is latency masking, because in real-time UIs you want to make sure that everyone has the same state. You don't want to have two people see totally different states of a document. But to do that, you have to actually emit patches and then get back the patches and see what are the states, or did my patch apply in the order that I expected it to. And that can be kind of hard, because you don't want to wait for the patch to actually get back from the server or some other peer in order to see the change reflected. Like, you can't click a key and then wait for a second before it actually shows up in your UI. So you probably want to implement optimistic updates, which is where you actually just assume that something is going to be applied in the same order, and then when you give back a change, that will be resolved in the state, and you'll just re-render the new state. And depending on your approach, this could be a very manual or very automated process. So AutoMerge, as I talked about, is just handling this for you under the hood. You'll just get a new state that you can start rendering. But other approaches, you might have to actually keep track of which patches you've sent, and when you receive new patches, you'll see whether that's the one that you sent, and then do a little merge or like a conflict resolution strategy. One really underestimated aspect of real-time UIs is just communicating intent, that I want to change this field or this location within the document. So when something magically disappears or changes in front of you, you get very confused. So the different approaches that I've seen on handling this are the classic Google Docs thing, where you have avatars and cursor positions or caret positions with names and like a unique color per user. I think that's a pretty established standard by now. But there's other solutions like Trello, for instance. They just magically mutate the board when something changes. But at least they have like a change log on the right, so you can see like, okay, someone actually moved this card from this position to this position. So there's at least some way to find out why something changed. In addition to being just an understandable UI, it's just extremely underestimated how important it is for not having conflicts. Because when a human sees that icon that someone else is in that location, they're just not gonna bother to do anything right then and there, because you don't want to override someone else's changes. So you can actually, usually, as long as you have a good like fine-grained patch system, you can avoid most conflicts just by showing that intent. And another really interesting aspect is that once we have AIs or machine learning on this same playing field, if you want some bot to actually change or annotate that document, that's going to also cause some problems for humans, because you might like fix a typo or something, or maybe suggest changes. And if that just randomly appears, that might be confusing, at least if it changes the content. So by making sure that scripts and bots and things like that have the same playing field, so putting them as a presence within the system is going to be quite important going forward, I think. So you can either do this as distinguishing them as bot actions. So Google Docs shows these new writing suggestions in like a blue squiggly line once you have something that they think can be improved. But you can also, if you're just actually modifying things, you could just implement this as some sort of robot avatar or something, just to actually say that there's a robot in here. You just have to make sure that these are actually shown for more than 3 milliseconds, which it takes the bot to actually up this thing. So you'll want to probably introduce some kind of fake latency so that it looks like it's spending some time there. So where does React tie into all of this? And the interesting thing is that a lot of these ideas, they match up extremely well with how React is built. So you have this automatically applied state, right? So this global state that I talked about, when you combine that with React and just being able to spread that state either down the tree as a renderer or just props to all of the components, that's a really efficient and easy to reason about way to actually apply that new state. But you could also do the subscription approach, where if you have a very structured document with a lot of different fields, you could subscribe to just parts of it and just like pick those out of the store. And also the concept of mutating state through a callback, and just in general React being about eventual consistency, it matches really well with the concept of distributing changes and waiting for those to apply, and then at some point you'll have the distributed state or the eventual state that you wanted it to be in. So when you're using the set state with the React and you get the callback pattern where you wait for it to actually be ready to flush the changes, and then you read from the state and apply it, that's very applicable in this scenario as well, because some of these conflict resolution strategies will have you wait until you get a new state and then say, how do you want to modify this, because there's been a merge conflict. So this is the current state, what do you want to do with it? Also, the React team has always been talking about they want you to move state out of the components, and that obviously applies here as well. You don't want each and every single component that's doing some kind of editing to maintain their own state. You just want it to be very simple, like this is the state that I currently have, this is the value, and when I emit changes I want that to be as simple as possible as well. Just say this is the new value I want you to have. There's a few interesting challenges posed as well, if you think about it, in terms of UI. So one of the lesser, it seems like a small problem, but maintaining cursor positions, like when you're writing text and someone else goes in and edits that in React, that usually causes the cursor to reset to the start of that input field. So you will have to actually implement some kind of algorithm to make sure that once you update that state, you want to reset it to the same location that you were, which might now have changed. Like you can't just say index 13, because if someone actually inserted text prior to position 13, that new index is somewhere else. And you also, there's this, like I said, propagating value changes should be as easy as just calling a function and having that be applied. Other things is like changes to content that causes size changes is kind of an interesting problem, because if you have like a array of things that's showing a list of things, and you're further down on the page and someone inserts something over you, that content that you're looking at will just get pushed down. So that's an interesting problem without really too many good solutions. You could try to implement some kind of, I'm looking at this thing right now, and try to maintain that state, like maybe finding the nearest element that you're to the top of your screen and try to match that. Or you could just implement like maximum length and scroll positions or show more buttons or something like that. Undo is a really hard concept in distributed systems, if you think about it, because what you usually have is like you write 2 paragraphs and you undo, and then it goes back half of that paragraph. But with these small changes, and the other users maybe sending you some patches, that doesn't mean the same thing anymore. So you might have to actually keep track of your changes and then try to create a reverse patch for that, which it gets really complicated. Luckily, some of these, like AutoMerge, for instance, has a built-in way to handle conflicts. Like it knows how to revert a change that you've done. But you'll have to keep track of, in many of these cases, you'll have to sort of fine-tune what it means to be undoing a change, because you don't want it to undo a single character. You want it to undo a logical batch of operations. So as for these carets, as they're called, or cursors, or whatever you want to call them, basically is the selection, the current position of the where you're typing something. Let's try to solve this in React, because it's a fun little problem that's not it's not trivial, but it's not hard. So I'll start off just by having a classic input component that's managed by a parent component. This is the pattern that I talked about, where you want to be able to just say this props on change and the new value, and then have that be distributed to some lower level patch system that actually distributes that change. And once that patch is applied, you get a new value back. And that container will also probably want to handle the optimistic update, so immediately give you back the new value. So in this case, there's this lifecycle component that I don't think a lot of people know about, called get snapshot before update. And it allows you to, right before an update happens, you can read some things from the DOM. So this is generally used for things like maintaining scroll positions and stuff. But in this case, you can read the value from, like you get the new props. No, you get the previous props, and then you already have the new props. So you can see, did the value update? And if that, then I want to read the current caret position from the document, or from the input field. Because you want to make sure that that doesn't happen 15 milliseconds before the actual update occurs, because then you get this weird one, slightly different position. So the way, I'm not saying this is like the perfect solution, this is just what I came up with. But one way to look at it is, if your cursor is at the end of the pretty word here, then you get a snapshot of the text around that location. So in this case, I'm capturing 4 characters before and after. And I capture that text. I also say where's the difference between the start of that text and a caret. Because if you're at the start of this line, then your cursor diff would actually be 0, and you'll just capture the first 4 characters. And then you want to record like the approximate location of the caret. So in this case, it's at index 13. And the length of the string, which means if you have actually selected something, that will be whatever length of the selection you have. And the search from is actually the start of the text thing, and the index is the actual index of the start of the selection. Once you have that, then you can implement component did update, which the third argument will get this snapshot that I talked about. Whatever you return from the get snapshot before update will be passed into component did update as the third argument. So if you check that for a snapshot, and if it has that, you try to restore the caret position. Because you don't want to do this on every keystroke, or not on every keystroke, but on every change. So if something else happens to the document, like some other prop causes it to re-render, you don't want to try to restore the caret position. And that's basically, in its simplest form, that's just getting the element from the DOM and then saying I want to set the start and the end position of the selection. Of course, applying it in actuality is slightly more difficult. So in Sanity, we use this this library that I talked about, which is called the diff match patch, which is the thing that applies these patches, text patches. But in combination to that, they also have just the match part of it, which allows you to make these to apply these match strategies. So in this case, I'm saying here's the current value, like the new value that that the server sent, and here's the text that I got in my snapshot, and here's the like approximate location of where that string was previously. And the algorithm is smart enough to actually look a bit it will search outwards from that position for something that's fuzzy equal. So that means it won't have to be the exact same thing, but it will try to match it as closely as possible. And if you find that, then you just say, okay, you have the new index, so you won't just want to set the start to be the new index, and then the difference between the text that you captured and the caret position originally. And if you couldn't find it, then you just use the old index. That's sort of the best effort you can possibly do. If you can't find the string, just set the cursor to the exact location it was at before the update. So that might seem like a lot of code, but it's actually not too bad. And hopefully we'll get in the next version of React a like React hook that allows you to implement these this get snapshot before update within the hook, because that's one of the few lifecycle methods that's not covered by that. So in that case, we might be able to just use a hook to be able to provide this functionality with a simple statement. Presence. I talked about that a bit, but I want to think about different ways that we could implement it potentially. So this is just sort of a brainwave of how you could implement it. I'm not saying this is the best way, but what you could do is basically make a roll call. So when you connect a new client, you have this WebSocket open that has just an echo server, basically. So whatever's sent over that socket is just echoed back to all the other clients that's connected, like a message bus. And so when you connect, you say, who's here? And then everyone that's listening just says, I'm here, and then just emits their presence there. The benefit of this approach is that you don't have to have a stateful server that has to maintain the state, which gets pretty tricky in a distributed system with lots of servers. Having to constantly keep track of that and make sure that there's never stale info can actually be quite complex. So sometimes it's just easier to make very simple dumb solutions like this. Just shout out who's here and get back who's there. Yeah. Sometimes you have to have the clients check in. So one thing is to say that they're originally there, but at some point you want to probably remove them if they don't, if they're not there anymore. And the simplest way to do that is just to make sure that they every 15, 20 seconds, whatever you choose, say I'm still here. And if the client doesn't see a different client for a while, they just remove it from the list. And in terms of knowing where a person is within the document, that's something that you can choose to do extremely fine-grained. Like with Prisma, they actually capture the cursor positions of different people, the mouse cursor position, which is crazy. But it's for them that's extremely important, but for other people it might just be enough to say I'm editing this document right now. So it depends on your use case, but basically it's about just having some kind of granular path to whatever you want to be able to show presence for. There's also this really cool API that browsers have recently implemented called navigator.sendBeacon, which you can use to register a URL that should be pinged once you close the browser. And this is guaranteed to actually finish. So it's not like sending in XML HTTP request, because that might be terminated when you close the browser. This will actually make sure that it actually completes. And you can send some data as well if you want. That's just a string or form data or something. So in this case, you could tell the server that I'm logging off, and then get that instant log off thing instead of having to wait for the next check-in roll call in order to see that the client has disconnected. This is one of the harder problems that I've tried to tackle, which is trying to re-implement the Google Docs style caret things. So I'm not going to show too much code here because I actually didn't. I thought I could do this in time for the presentation and show an example, but I didn't actually manage to do that. But it's basically about this is how hard it is. You have to create a div clone of the text input that you want to have the cursor positions for different people for. And then you want to apply the exact same styles from that input to the div. And you want to fill that div with the same text as is in the input up to the caret. And then once you're up to that point, then you insert a new span and insert the rest of the text. And so now you can measure that span's position. With this is all like drawn off screen, but you'll get the same position as the input. And then you can draw that on top of the original input as a sort of an absolute container that just floats over this position. And you'll have to do this for every key, or whenever someone's caret changes within that document, you have to do this. So there's going to be a lot of like drawing off screen, which is quite CPU intensive in the approach that I found. So I'd be very curious if anyone knows a really efficient way to do this. That would be awesome. So talk to me if you found a better solution for that. So my point with all of this is that I think we have the pieces that are available, and I think we should start to try to think about whenever we make a UI that this could this be written in a collaborative way, and if so, what are the steps that's necessary to handle this? Just being able to handle at least locking in a way that doesn't cause any like unexpected behavior, like someone overwriting your precious changes. It's going to make the web a much better place if more people think about that kind of stuff. So we have the pieces, but we need kind of bigger building blocks. And I think it's time that we start talking about how we can implement those in a reusable way. So a lot of the things that I've been talking about today, like caret positioning and stuff, it shouldn't be that hard. It should be like a problem that can be solved either with a simple module, or maybe we can have some better browser APIs that allows us to do these things. So if we could start building these things, then I think we could all benefit, and at least we'd have somewhere to go, a place where you can discuss and try to figure out the best solutions for these things. It's not going to be easy, obviously, but it's definitely not impossible. So I would recommend people start to try to think about these things. And yeah, that's all I have.
Maybe someone has questions? Okay, I see.
Thanks, Espen, for a great talk. I wonder, how do you test those? How do you test your application? Do you have some automated tests? Or maybe you have some scenarios when you test some concurrent actions for your application? So how you test those tricky UIs?
Yeah. So for the actual text editing, or the real-time patching and stuff, that's quite a difficult thing to actually implement. So you want to make sure that you get the timing right, because you need to make sure that all of those like combinations are handled. So but even then it's very hard, because the server, could be like small network latency issues that could cause some flake and different predictability in terms of what the end state will be. So so yeah, you probably writing those tests within as isolated non-browser tests is the best approach for those. And in terms of these caret repositioning things, those are actually a lot easier. You can actually use just update state using like jest and enzyme and all that kind of different React tooling. Just pass it a new value and make sure that when you read from the DOM, then those are the same values as they previously were, or the same caret position, expected position.
Some more questions? Yeah, I see.
Hello, thank you for the speech.
Thank you.
I have a question. Do you build your editor from the scratch, or you are using some rich text editors like Draft.js or else?
Yeah, we use in Sanity. We have for most like basic inputs, we just use like standard input and text area and stuff. But we also have a portable text editor, which is based on Slate, Slate.js. Which handles a lot of these things. Like there's it's been given a lot of thought into collaborative editing inside of that, so they have a bunch of the primitives that we need to be in order to like emit the correct patches.
If no more questions, thank you.
Thank you.